Hi everybody, welcome back to class. Today we're going to keep going in section 6.5, talking about the remainder and the factor theorem. Now that I have sufficiently made you guys all upset enough by having you do long division, now I'm going to show you a little easier way that we can do some problems, okay? Be careful with this. Do not overuse this because this only works in a very specific situation. Otherwise, that long division does still come into play. However, if I have a polynomial divided by x minus some number k, okay, so that means you have to have the setup of, for instance, x minus 3, okay, x minus some number, and it has to just be x. It can't be 2x minus 3. That doesn't work. That's why this is a very specific situation, okay? Then the remainder is whatever that polynomial is evaluated at whatever number you're subtracting from x. Be careful here. If you see, for instance, x plus 3, we can actually make that work as well, but that k is going to be a negative 3. So we actually have x minus negative 3. That is still okay, but again, it just has to be x plus or minus a number. So what does this really look like? What does this really mean to us? If you were going to divide x cubed plus 2x squared minus 6x minus 9 by x minus 2, okay? This is the setup that we want. X minus 2, that's fine. That means our k value is 2. And I'm going to show you a process called synthetic division. Okay, this works a lot better than that long division, but it has to be in the setup of x minus some number, in this case, x minus 2. If you're wondering where you've heard synthetic in this class before, yes, it is going to be the exact same process as synthetic substitution that you just had a test on Wednesday. Okay, our k value is going to go up into the box, okay, up into the corner, up into the box. We list all of our coefficients. I have x cubed, x squared, x, and our constant term. Okay, so I don't need to worry about plugging any zeros. If I were missing one of those, I would have to plug in a 0, just like I do with synthetic substitution. So I'm going to go 1, 2, negative 6, negative 9. And I draw my line down below. And this works exactly like synthetic substitution. Drop your 1 below the line. 2 times 1 is going to give me 2. And I add down my column. 2 plus 2 is going to give me 4. 2 times 4 is going to give me 8. And negative 6 plus 8 is going to give me 2. Times 2, up in the corner again. 2 times 2 is 4. That goes there. Negative 9 plus 4 gives me negative 5. And I like to put that negative 5, that last number, inside a box going the other way, just like I do the 2 up in the corner. Now, here's the cool part about synthetic division. Okay, with synthetic substitution, I told you don't worry about anything besides that last number, and that last number is all we want. Okay, these numbers actually do have meaning. Okay. This negative 5, okay, from our remainder theorem that we just talked about on the first slide there, this is our remainder. Okay, this 2 is our constant term. Or if you want to think of it as x to the 0. Okay. This 4 is the coefficient in front of x, and this 1 is the coefficient in front of x squared. So instead of doing all of this long division, I can actually write out x squared plus 4x plus 2 and minus 5 all over x minus 2. Okay, this always works. My biggest advice to you, start on the right side and work to the left. Okay, it's not always going to be that this first number here is an x squared term. Maybe it's just an x. Maybe it's an x cubed. So your powers of x have to go up by 1 each time you move to the left. So start at the end, that's your remainder. Work to the left, get powers of x. Then these numbers underneath your line, so your 1, 4, and 2, are going to be coefficients in front of those x terms. And if you went through the long division process, you would get this exact same thing. Let's take a look at one more. Okay, we're going to have x cubed plus 2x squared minus 6x minus 9 by x plus 3. Okay, up in your corner, your k value is always going to be the opposite sign of what you have. I'm given addition, so k is actually going to be a negative 3. So negative 3 is going to go up in my corner. List all my coefficients. Do I have all my powers of x? I have x cubed, x squared, x, and a constant, so I'm good. So I go 1, 2, negative 6, negative 9. Draw my line. Work through the same process. Drop my 1 down. 1 times negative 3 is 3. Negative 3. 2 plus negative 3 is negative 1. Negative 1 times a negative 3 is going to be a positive 3. Negative 6 plus 3 is negative 3. Negative 3 times a negative 3 gives me a positive 9. Negative 9 plus 9 gives me 0. So I box off my 0. Okay, that's my remainder again. Which means negative 3 is my constant. This is my coefficient in front of x. My 1 is my coefficient in front of x squared. So to divide this out, I can write out x squared minus x minus 3. And since my remainder is 0, I don't have to have anything. I can just leave it as this. Remainders of 0 is nice. Okay, so same thing. Just do your synthetic division. Work from right to left. I know that's backward. Everything we do is typically from left to right. Go from right to left. Figure out your powers of x. And if it helps you to label them out underneath of it, do that. Okay, you just those small things that can help you get these problems right. Then, the factor theorem says that if a polynomial has a factor of x minus k, if and only if that polynomial evaluated at whatever that k value is equal to 0. So what we're looking for here is a remainder of 0, essentially. That's why this is called the factor theorem. We're seeing if that number is going to be a factor. So we're going to factor 2x cubed plus 11x squared plus 18x plus 9, given that f evaluated at negative 3 is 0. Okay, this is just a different way for me to ask you to do the exact same thing that you've been doing before. However, we're going to do just one more step when we're done here. Okay, the nice part about when I ask you to factor this negative 3, this is my k. So negative 3 is what's going inside the corner, inside the box. So I'm going to go negative 3. I double check. Do I have all powers of x? I've got x cubed, x squared, x, and a constant term. I do. That is perfect. So I go 2, 11, 18, and 9. Now, we know that this is equal to 0 when we plug in negative 3. So we should end up with a 0 remainder, but we want that polynomial that comes out after this. So we're going to go through our synthetic division, drop my 2 down below. I get 2. 2 times negative 3 is negative 6. Negative 11 plus negative 6 gives me negative 5. Times negative 3 gives me a positive 5, not a negative 5. There we go. Then I get a negative 15. And 18 plus negative 15 gives me a positive 3. Positive 3 times negative 3 is a negative 9, which gives me a 0. So that means, okay, 0 is my remainder. This is my constant. At 3, 5 is the coefficient in front of x. 2 is the coefficient in front of x squared. So that means if I want to get 2x cubed plus 11x squared plus 18x plus 9, I can take (2x squared plus 5x plus 3) and, okay, remember how I told you that we're going to take the opposite sign of whatever is in the box. So I'm putting a negative 3 here. But remember, we need to have things in the form x minus k. If I'm going to subtract a negative 3, that's actually going to be times x plus 3. Remember, opposite sign of this is what goes in the box. Okay, so you see a positive 3, negative 3 goes in the box. And now what we're actually looking to do is I want to factor this 2x squared plus 5x plus 3. This looks like something we can do. This looks like something we've done before. This should not be too much of an issue for you. You can use your guess and check, or you can use your AC method, or whatever method you use to do these. I know there are others out there. So I'm just going to go with a little bit of guess and check here because I think I can get that. My third set is always going to be x plus 3 here. Because that just keeps tagging along. So I'm going to ask myself what multiplies to 2x squared. Well, 2x and x do, so I'm going to put 2x in one set, x in the other set of parentheses. I look right here in front of my 3, and I see that that is a positive, tells me that the signs are going to be the same. So I look forward to in front of the 5 to see that they're both going to be plus. And I need numbers that multiply to 3 and add to 5. I'm going to go with 3 and 1. And if you want to double check this, I would recommend it. Okay, multiply your 2x times 1 to get 2x, and 3 times x to get plus 3x. Okay, 2x and 3x add to 5x. So we have factored this correctly. So our final answer here is going to be, in parentheses, 2x plus 3 times x plus 1 times x plus 3. And if you were to FOIL these out or box this, you would actually end up with the polynomial that we started with, that 2x cubed plus 11x squared plus 18x plus 9. If you guys want to go ahead and do that, you can. You don't have to, but that's a good way to check to see if you got this factoring correctly. Okay, then there's your homework. We'll check this when I get back on Monday. If you guys have questions, feel free to shoot me an email or stop in sometime, and we'll get you squared around. Other than that, you can work on this, and we'll check this when I get back to class.